Hi, guys. Yes, here we go. So, my name is Berenice. I am a lead data analyst at Avis. It's a small startup. And today I'm going to talk to you about data jobs because being a data analyst is not my first career. I used to be a chemist and then I transitioned to this new career. First, before I talk about working with data, I want to tell you what I know about tech companies and how they work. So this is just a general overview. So we know what we talk about. We're on the same page. I'll tell you where data people work in this structure. Finally, we'll talk about data titles. And if there's time left, I'll tell you a little bit more about what I do. Just want to give credit to Michelle Lay because some of the material I'm presenting is inspired by her presentation, which unfortunately is not shareable. So, a tech company, what makes a tech company? First of all, you always have customers, whether it's people directly, businesses, developers. It ties a little bit. It ties nicely with what Joel was saying. So I'll try to refer to his talk as much as I can. So that's outside the company, but the company interacts with them with multiple teams. So you have marketing people, user experience people, sales, and usually customer support. And they all take input or they reach out, you see the arrows here, to the customers and they report to the product team. So that's something Joel mentioned too. For example, customer support would say, hey, we're getting a lot of calls because this feature is down from our website. The user experience people would say, hey, the form that you have to fill to become a new customer is really difficult to understand. So can we try to work on that to make it on just one page, for example? And then the product team would take all this input from the various departments and they will task the engineering team and or the design team, depending on the problem, with developing the feature or fixing the feature. So they work together. Sometimes they go back to the product team saying, hey, you said this was the top priority, but it's actually going to take months. Why don't we do the second priority first? And again, it's the responsibility of the product team to give the general strategy and prioritize the tasks. So the engineering team has fixed the feature that was broken. They have developed the new form with the design team. What happens next is they work with QA. So that's the quality control. They're going to test your features and try to really break it, make sure that everything works the way it's supposed to work. Sometimes they will send work back to the design team or engineering team. And after they've thoroughly tested everything, they okay the new feature. And then who is responsible for really giving it to the customer is the DevOps people. They're very important. They have a lot of pressure because they work on the infrastructure side and they make sure that everything the engineers have developed works. It doesn't break anything that already exists, and they make sure that it can be delivered to the customers in a suitable fashion. So they finally launched a new feature, and the customers are super happy. Um, Everything goes well. Is that all? No, we have a few more people in a tech company. Again, this is a general overview. IT people support, and these two groups, they support the other guys. IT by providing all the equipment they need and really the infrastructure. And then people ops, that's HR, payroll, you have finance and all that. So this is just the overview. And it's a good idea to kind of see where you would think you would want to land if you want to work in tech. Where are the data people in this organization? Well, they're everywhere. So you have people working in marketing, like all these departments. It's just not very common for most tech companies to have a data science team, really, unless their product is data. Like my company, we work with data. That's our core business. So we have a data science team, but most companies do not. They just hire one analyst, one scientist here and there, and they get to work on all these different aspects of the company, but there's not a team dedicated to that. So again, if you want to work with data, think about where you would want to work, what would suit you best. Because if you sort all these departments on the spectrum between business and engineering, you would have product kind of in between, making the link. Business is typically facing people, and engineering is typically just coding and being facing your computer. So again, think about what you like, what kind of profile would work best with you. All these people work with data, either with the business side, where it's more analyst jobs. Product side would be more scientist jobs, roughly. And then engineering is data engineers, obviously. In terms of the demand, what we observe is that as of now, it's mostly there is higher demand in business and engineering, so data analysts and data engineers, more than data scientists. And that's because companies need to be kind of mature before they can spend money on this side. So usually they want to have a higher return on investment, and they will focus mostly on the two ends of the spectrum. And the predicted trend is that this is going to evolve even more in that direction. Companies will invest mostly on business and engineering people when it comes to data. So now that we have kind of the same frame, I can finally talk about data titles. And I've been avoiding this mostly because there's no real standard across the industry. So you'll find a lot of job offers that claim that they're hiring a data scientist or a data analyst, and it's just not standardized. So you really need to read through the requirements, the qualifications they ask for, because sometimes it's advertised as a data scientist job, but it's really doing analysis. So um, there's no standard across the industry. Again, on this spectrum, if you want to start by being on the business side, you could be a business analyst, business insights analyst. For example, you'd have a business background and do nice reports, try to find insights in the data to help stakeholders or even customers navigate the system. If you move a little bit towards product, you could be a product data scientist, for example, and you look at how users interact with the product on a website. For example, if the company is developing a website, say Zillow, you look at how much time each customer spends on each listing. You will try to figure out where they click, and you will try to improve their experience. That has to do also with user experience research a little bit. Moving again more towards products, you would have product analysts. So they would have a challenge like how to engage people aged 30 to 40 in Snapchat, and they would try to look at these new markets. So it has a lot of communication and also business pitching and financial. And we'll try to figure out when is the best time to launch a new product and things like that. So that has more predictive components to it as well. Moving a little bit further, again, towards engineering, you can find predictive modelers, and that's what I like to do. That's typically a data science training where you will try to predict something, predict a performance, forecast a trend, something like that. Usually you would be a scientist of some sorts, have a stats or math background. One example is to build a spam engine. If your company does emails, how do you know which emails you need to send to the spam box versus the regular inbox? Further towards engineering, you have algorithm engineers. These guys are really into the theory. So the people I've been talking about so far, they work with existing algorithms. They don't develop new technology. They use something that exists. There are also people who create these algorithms from scratch. So usually they have a PhD and they're really heavy on the computer science side. They would, for example, for when Netflix recommends the next movie you should watch, this is a technology that they develop. The recommendation engines are pretty complicated, so they would have engineers that were just on developing the technology to support their predictions. And then further in the engineering, in the more classic sense, you have data engineers who work on the infrastructure. They make sure that you collect the right data for everybody else, really. So when I said that the product data scientist looks at how much time people spend on the website, where they click, It has to be collected at some point. Who collects that and they need to make sure that it's stored. They need to make sure that it scales. They also need to take into account the fact that do we want something that streams live, or can we wait until the end of the day to fetch the data? Because that has a lot of implications in terms of computer power and all that. So very important people. They kind of work under the hood, and we don't talk about them that often. In terms of career progression, and this is an kind of an entry level talk, so we will focus on the bottom of the of the chart. We have data analysts, scientists, and data engineers. Those have the word data in their job title. There is a common misconception that you have to start as a data analyst and then you become a data scientist. That's not necessarily true. Um, Technically, the difference is more reporting and analysis versus more predicting machine learning for scientists. But it's not uncommon to move up from data analyst to data scientist. The other path up would be to become a manager. So that means supervising people. And that's something you need to think about. Again, Joel talked about that. He knew that he wanted to remain technical. If you really want to remain technical, the path up would be to become a principal or an architect. So you don't supervise people, you really work on code, but you're the head of that. If you want to progress in the company and become a manager, depending on which side of the spectrum you are, you can become a product manager or engineering manager. And so this is a good way also to answer that question in job interviews when they ask you, where do you see yourself in 5 years? Those are suitable answers. So I want to remain technical. I want to do something that's like an architect, or I would like to supervise people eventually and take the manager's path. Just for the record, there is a third answer that's suitable. It's if you want to start your own business, you have entrepreneurial spirit. So that's also something you can say, and that's accepted and understood at a job interview. So this is the start. We can talk about the upper side, the upper part of the scheme later. But that's about it for the data titles. And I think I have a couple more minutes so I can tell you what I do. So I work for a startup called Avis Precision RX. And what we do is we're trying to find the correct treatment for type 2 diabetes patients. So it takes on average a year and a half if they go to their physician and the physician decides that they have type 2 diabetes and they need to be medicated. And it's by trial and error. So there are guidelines, but there is no guarantee that one drug will work for a patient just because they have so many side effects. And usually when you have type 2 diabetes, you have other chronic conditions, or not necessarily chronic, but you have other conditions. So it's very difficult for physicians to find the correct treatment. So what we do is that we use EHR, that's electronic health records, and we try to predict the best treatment for the next patient. Our advantage is that unlike endocrinologists who are highly trained and they're very good at their job, we are going to be able to see millions of patients. Endocrinologists will see thousands maybe in their lifetime. And hopefully the computer can find patterns that are invisible to us humans and physicians. So the goal would be to have a tool that sits in the physician's computer, and whenever they have a patient come in, we would give them a recommendation in terms of the treatment that would work for that next patient. So that's really data science. I'm making predictions, and we're building the tool from scratch, which is really interesting. I think that's all I have for today. I hope I provided some useful information. And if you have any questions, you can always email me or find me on Slack.